Hi everyone, I'm Professor Rad, and today we're going to wrap up Chapter 7 by applying multiple techniques to simplify algebraic expressions. Primarily, we're going to either use the associative or the distributive property. We might use some product properties or power properties of exponents, and then we may also be using the combining like terms property or technique. So let's dig in on example A, and I'm just going to walk through what I see and what it tells me. This is one of those things that the more of these you do, the more you practice, the easier it will become to see these patterns to identify what to do. But when we're starting, it can be pretty tricky because we don't know what to look for, so it makes it harder to know what to look for and what to do. So what I'm noticing is that I've got parentheses around one thing and parentheses around another thing. There's nothing in front of this set of parentheses, but there's a minus sign in front of this next set. And I remember if there's a minus in front of a set of parentheses, that means it's going to change the sign of everything on the inside. So I'm going to start with that. I'm going to cover up this first part, and I'm going to distribute this minus sign on the outside to everything inside. So what it does is it makes this positive 2n squared into a negative 2n squared. This plus 8n becomes a minus 8n. And this minus 3 becomes a plus 3. Now, this piece over here had nothing in front, so it's kind of like I'm multiplying everything by 1. I don't need these parentheses here. So I'm just going to rewrite it, but without those parentheses. So after this first stage of simplifying, I end up with 5n squared minus 2n plus 3 minus 2n squared minus 8n plus 3. Okay, now just like when we had our order of operations, it can get really overwhelming, so you want to make sure you breathe and just kind of clear out your brain from what you just did. Pretend like you didn't do it. It doesn't exist. We're starting fresh and clean with this problem here. So if I were just seeing this, I would need to combine my like terms. So I've got a 5n squared, got an n, nothing, n squared, n, nothing. When I'm combining like terms means that I add the coefficients, those numbers, in front, and nothing happens to the exponent. The exponent's just part of the letter. It's like a label. So we have 5 minus 2, which is a 3. Then we have, here's with an n, here's with an n as well. So minus 2 minus 8 is minus 10. And then we have plus 3 is 6. Cool. Now, I'm all done. So I know that I'm done because there's no other operation I can do. I don't have any powers to powers. I don't have any regrouping to check out. I can't combine any of these terms because the exponents are different. So that's going to be my final answer. Let's take a look at this next one. We have 6m times 3m squared plus 5m minus 2. So there's nothing between the m and the parentheses, which means we have distribution. The 6m, there's nothing in between the 6 or the m. So when I do my distributing, it's going to be this entire factor. This whole thing gets distributed. So I'm going to distribute to the 3m squared, the 5m, and the minus 2. So I'm going to write that like this. I'm going to write my 6m times 3m squared plus 6m times 5m minus 6m times 2. Okay, so we did our distributing. Now I've got these chunks that I can simplify. And I'm going to simplify them using a combination of associative property and product property of exponents. Here's what I mean by that. 6 times 3 is 18. 6 times 5 is 30. 6 times 2 is 12. That's my associative property in play here. I'm kind of grouping it so that I'm just multiplying the coefficients, the number parts. Now I have to deal with the variables. Remember that m with nothing outside has a secret exponent of 1. So I'm going to put this here to help me. Because when I do m times m squared, I need to add the exponents. That's the product property of exponents. So 1 plus 2 is 3. 1 plus 1 is 2, so I get m squared. Oh, and there's just a single m here. So my final answer to this one is 18m cubed plus 30m squared minus 12m. Now, that was me working through this problem, breaking it into parts. I'm going to work through it again, but break it into less parts, because sometimes breaking it into parts helps, and sometimes it makes it feel overwhelming and confusing. So let's see if you found this overwhelming and confusing. If I just don't break it into any more parts, I just kind of work through the parts in process, you might like that better. So I'm going to rewrite the problem over here. And again, because I'm going to be multiplying variables, I'm going to add the exponent right in there. Okay, so here's how I would work through this. I know I'm going to have to use the distributive property. When I distribute 6m to 3m squared, 6 times 3 is 18. 1 plus 2 is 3. So I multiply big numbers, I add little numbers. Plus, multiply big numbers, 6 times 5 is 30. Add the little numbers, 1 and 1 makes 2. Bring down the minus, multiply the big numbers, and then I have an m, I don't have any more m's. So I get 18m cubed plus 30m squared minus 12m. And that's the same thing we got here. So if it helps you to write out the separate steps, because it's clearer to see what you're doing, feel free to do that. But you can also work through this in one go without writing out those steps, and you might find that easier as well. So again, it's up to you what makes the problem easier for you to think about or easier to solve. Let's do one more example together. I've got 8x to the 7th times 3x to the 5th squared. Okay, so the thing I notice about this one, there's no adding or subtracting. So that means no distribution, no combining your like terms. You are just multiplying stuff. So you might be tempted to do 8 times 3, but there's a problem. And the problem is that the 8 is free, but the 3 is trapped in the parentheses by the squared. So I have to deal with this squared first and foremost. Okay, it's kind of like a guard on those parentheses. So I'm going to cover up what's not in the parentheses. And remember, this exponent gets applied to everything inside. So this is going to be 3 squared. And then when I have a power to a power, I multiply the powers. So 5 times 2 is 10. Now, 3 squared is the same as 9, so I can write it like that. In front of that, I have this 8x to the 7th. Okay. Let's see. So I've got 8 times 9, which is 72. I multiply the big numbers. And then I'm going to add the little numbers. So 7 plus 10 is 17. So that becomes 72 times x to the 17th. Okay, Professor Ed, this is nice and all, but how do I know if any of this is correct? Like, as I'm working through this, how do I check my answer? That is an excellent question. So one way that you can check your answer, I'm going to check my answer to this one, is you can replace the letter with any number and see if it works. Now, usually you don't want to pick a number that's too big, but you also don't want to pick a number like 1 or 0. So let's just do, I'm going to pick 2. So I'm going to put 2 where I have that x. And remember, since there's nothing in between, it means times. If I get the same thing when I substitute into here as I do here, then that's good evidence that my work is correct. Not perfect, because I've only checked one number, but it at least gives me a little bit of a, more confidence. And I could try some more questions too, or more numbers too, if I wanted to check. So let's do 8 times 2 to the 7th power, parentheses, 3 times 2 to the 5th to the 2nd. Okay, I'm going to write that down, probably on scrap paper, but I'll put it here, 9437184. So you can see why I don't want to pick something too big, because then this is going to get huge here. And then let me try 72 times 2 to the 17th. Yes. Okay. So this is good evidence that we likely didn't make any mistakes. You do want to avoid using things like 1, because 1 to the 17th is 1. So if it should have been 1 to the 5th instead of the 17th, I wouldn't have caught that. So picking numbers like 2 or 3 or something like that might help you do a check a little bit nicer. And so that's it for this video. So I have 3 more expressions for you to try and simplify it on your own, see how you do. That's going to wrap it up for chapter 7, which means we only have one more chapter left. We're going to look at chapter 8, where we start to put these more abstract concepts we've been working with, these expressions, and put them to use to like actually solving some problems. So I'm looking forward to seeing you then. In the meantime, have a wonderful day. Bye.